Thank you very much for downloading this webcast and welcome to the SharePoint DevWiki webcast. My name is Jeremy Thake, I'm the founder of the SharePoint DevWiki. Today we're going to be covering SharePoint 2007 development and how continuous integration can be implemented inside Visual Studio 2008, leveraging Team Foundation Server 2008 and specifically focusing on the team build component of that platform. We'll be focusing on a WSP builder project and highlighting the quality inside the code and how that can be leveraged. Hopefully by the end of it you'll see the advantages of what a build server can do for your development processes. So some of the common mistakes made in the development process are around the fact that typically the WSP packages that are built and given to the administrators built directly from the developer's machine that they're working. That might be a virtual machine that they're running on their own PC or a shared development environment PC where they've got the source. Now the problem with that is that that's fine, it's going to work on their machine when they build it because they have all the source files on there. But occasionally what will happen is that an administrator will find a bug in the WSP that's been deployed in production, and there's already been changes to the source in the developer's machine, and they want to know exactly what the source snapshot was of the WSP in production so they can troubleshoot an error. Now this is often quite hard because typically the assemblies are always deployed with version 1.0.0.0 inside the DLL, and tracking any sort of versioning in that any other way is next to impossible unless you use something like Reflector to do so. So what I'll be doing today is showing you how we can resolve this issue of being able to get back to the exact source control for a particular WSP that's in an environment, and also to, as I mentioned before, to highlight the issues with the code as it's checked in. So we're going to start off by setting up a completely based project inside Visual Studio, and I'll be using Visual Studio 2008, and as I said before I'll be using WSP Builder to create myself a solution package with a web part in it. So when we open up to Visual Studio, it will actually prompt me, because I have Team Explorer installed for my TFS user account. Now I'm using a development TFS server here, and what I'm going to do is the first thing is I'm going to create myself a new team project. So we're going to call this Hello World 4 because that's what I'm up to at the minute. And we're just going to use the basics process guidance because I'm really only using this for source controller and build at the moment. And again the default's all here. Now this will take a little while to run. Okay, so this is nearly done now. As I say, this can take a little bit of time to spin up a team project in TFS, especially when you're running on a development one. I'm just going to uncheck that because I don't even need that to open up my process guidance because I'm not concerned with that for this example. And the first thing that I always do with a TFS project, based on the TFS branching guidance available on Coplex, is to create a structure here. And I always start with a main branch, and I work within that main branch, and I put all my source control within the sources here. And this will make more sense as we go along through this process. So I can now create my Visual Studio project based on the WSP Builder project, and you see that I'm going to put it within the main source of my new team project, and we'll call this the Hello World 4 WSP Builder project, and I do want to add this to source control. Now you immediately see that it's actually put this within source control. And the first thing I'm going to do is I'm going to add myself a web part to the project. So I select down on my WSP builder and select my web part feature, and I'm just going to add Hello World 4 to my web part features in there. And we're going to make this at site level because that's where the web parts are actually activated on the site collection. And you'll see now that that's all added, all this stuff. I'm just going to close down that window. Now the first thing you'll realise is if I right click on here, it's actually referring me to the 12 Hive for this DLL. Now the problem is in an environment where you have a build server, all of the assemblies that you are using as part of your solution need to be available to that build server. Now obviously you don't want to have your build server with SharePoint installed in it. It should be just a simple Windows server with Microsoft TFS Team Build installed on it. And so it's very light, and so you need to actually add all the required assemblies. So what I typically do is I have a folder called Supporting Assemblies within my source control, and I will add the DLLs as I use them directly into my source control here. Now all I need to then do is go remove, click add reference, and go and make a cup of coffee. Oh no, that was relatively quick. And click up. One thing you will notice when you do this is if I right click here and go properties, you'll actually notice that that's actually pointing to a file in the 12 Hive. Now the issue here is that when you create a build server, you typically don't want to have to install all the related assemblies and products just to be able to build this project. So you actually need to include that as part of your branching here. Now the reason you do it in the main branch is because if you did it right at the top of your team project, you may have in a branch, you might be trying to use the latest DLL of a particular assembly, and so if that was the case, then it would require to be inside the branch for you to be able to have more than one assembly version running within this team project. So all I'm going to do is I'm going to go to that folder, which is basically that one there I've just copied and pasted out, and I'm going to come into the sources directory, and I'm going to create something called Supporting Assemblies for this source, and I'm just going to drag and drop that SharePoint DLL in there. And now when I right click and click add references, I'll be able to add that again. So fingers crossed, when I go right click and build, that's going to succeed. So I've got a completely isolated team foundation project there, which has the web part in it with the required assembly. So that will effectively run on a team build server, and a team build server is typically just, as I said before, it's very light. Just has Microsoft Visual Studio Team Foundation Server Team Build installed on it, and so therefore you have to push all the assemblies with it. So I'm just going to check all this in now. I'm just going to click on that, and you'll see there that there's a filter by the solution. Now obviously filtering by the solution is actually not going to include those files there, so I do actually need to uncheck that. And I do need to come in and everything inside my Hello World project. So I've got stuff checked out of one of my other projects as well. And you'll see why in a minute, because I'm going to use some of their files. So I'm just going to put first cut with new web part. And again, that's going to check all that into source control on TFS now. So the next thing I want to do is, now we have that in TFS, I want the team build to actually take that source control and build it on another machine. So that if a developer tells me it works on my machine, I can immediately be able to go by looking at the builds that have been run, whether it will actually indeed work on a build server or not. So the way we do this is we go into Team Explorer, and we have a look at the builds for this project. The first thing we need to do is make sure there's a build agent for this team project. Because this is a new team project, we need to actually create one. So in my example, my TFS server is my team build server. But in most environments, as I say, you'll have that as a separate one. The second thing to remember with build agents is the working directory that they use. Now, SharePoint projects naturally have quite long path names for their files, because you have the 12, you have the template, then you have features, and then you have the feature folder name, and then you have all the files, and you may have subfolders with files in those. There is actually a limit of 259 characters, and often if you leave this as default, when the build server tries to do a get latest, because the path is over the 259 limit, you'll start getting errors. So I'd recommend, rather than using the $temp there, is to actually enforce that to ctemp instead, so that it's as short as possible. I mean, to be honest, you could just go to CT as well, but anything to make that as minimal as possible in length. So I'm just going to save that. Now that we have a build agent that's going to be able to run our builds, we now need to create a build itself. So what we do now is we do a new build definition, and we're going to call this one just Hello World 4. And by default it gives you the root of the team project, but because we've created our branch here, I'm actually only going to be required to pull down the source, because that's all I'm only dealing with the source when it comes to builds. And also it's important that you branch your build files as well, because what as a scenario is that you may branch off and let another few developers start looking at another tool set or something to add to a project, and by having the build file branch you can set up two builds, one for the main branch and one for the new branch which the other developers are working on, and you'll most likely require two different build files to handle the branches. So it's always best to branch your build files as well. Now this, just putting this here doesn't actually create it. What you actually have to do is click create button there, and this gives you a bit of a wizard to build you a default MS Build team build project file, which I'll be walking through further in more detail. So we'll select that, and we'll just take the defaults for everything else. Now this goes away and that creates that actually within the TFS source control. It doesn't immediately bring that back and put that locally. We'll grab that in a minute. Okay, so that's created that project file. So now, let's close that. We can deal with the retention policies. What the build server does is it creates the files and it puts them in what's called a drops folder. And you can decide whether you want to bother keeping the builds for failed ones or stop ones or partially succeeded ones. Now, I would recommend when you're first writing your build files that you leave this as default, so that everything on here is all the errors are being stored. And then obviously we're selecting that build agent, and the next thing to remember is that we want these to go in the drops location. So you can see here I've already got some other TFS stuff going on in here, and by default it's that the check-in do not trigger a new build. When you're working with your team builds, I would recommend that you have your check-ins don't trigger, and that you do these manually until you're happy with your project file. So that's now created this new team build definition here. Now we can actually go and queue one up. So just right click and queue, and we can just take all the defaults there, and now what we get up is our build explorer. Now what that's actually going to do is, by default, it's basically going to call MS Build and build that solution file that we've ticked in that team proj build definition. So all it's going to do is compile the DLL. So it's exactly the same as if I'm in Solution Explorer down here and right clicking here and going build solution. So it's not going to create your WSP package, it's simply just going to create your DLL as required. So if I actually look in and double click on here, you'll see that it's initialized the build, and up the top there will give you your progress. And you'll see here that it's actually pulling down the sources locally onto the build server, and then it's labeled those sources and it's compiled them and it's completed, and we've got all green lights. So the first thing I typically do is, if I click on this up the top, you'll see here that this is the drops folder for this build. So that's build number 1, and it basically puts the date on it as well. So if we have a look in the releases folder, you'll see that there are the DLLs that have been built from that. Now if I go back up one, you'll actually see there's a build log, and the build log is linked from inside the information here as well. So if I click on here, it's easy to open it in Visual Studio, and you'll see there's quite a lot of verbose information here about what's going on, and you'll be digging through this stuff as you write your build scripts. I can guarantee you that one. So now we have a Visual Studio project inside TFS source control with a running build server. So now that we have our Visual Studio project running inside our build server, the next thing we want to do is add a build stamp on there. The reason we want to do that is because there are often the cases, we said, where an administrator is on a box and they have a look at the assemblies that have been created with the WSP file, and they've got no idea how to relate it back to this unique build number. Now when I say unique, the reason I say it's unique is because if I actually come in here and go get specific version, I can actually save for a particular chain set what's gone on. So in that case, if I got chain set 1, that would actually pull me back the exact snapshot of source control to be able to create these DLLs again. That's very important when you're debugging things and trying to replicate errors in your own development environment, because there could be all sorts of branches going out there. So the first thing we need to do that is we need to actually get our team build definition file down. So I'm going to go into source control here, and I'm just going to refresh this view, because now you can see that it's pulled down the team build types folder, and there's my team build definition folder, because we can have multiple builds within this one team project, and we have this tfs build.proj file. And you'll see here that this is all the default stuff that wizard created when we created this build and clicked on the create button initially. And this is all the instructions, default bits it requires to do the build. So you can see here that this is effectively what it's doing. So a lot of the rest of it's commented out or is blank. And you'll see here that it's actually going to go away and it's going to build that solution project for you. So now it's done that, we want to actually start doing other things as part of this build. So what we want to do is I'm just going to grab some code and put this in here, and typically you would always go and grab this from another project you've already done. And you'll see what I've got here. So the first thing I'm going to do is I'm going to actually go and import a project definition of more MS build tasks that are on top of what you get out of TFS. And the one we are actually going to be using from that is this filesystem.file. Now what we're actually going to be doing is right after the build has been been grabbed from source control and pulled down locally, we're going to call the build stamp target, which is our custom target here. And what we're going to do is say for every single project which meets these requirements where there's an assembly.cs, so effectively this could be any solution project name underneath our root path, our project, then we're actually going to go and we're going to replace something within that file. So what we're doing here is we're going to replace, and we're going to take and try and find the TFS build number using regex, and that can be a bit more complex if you want it to be, and we're actually going to replace it with the build number. So remember how we showed you that build number here? Well, that's actually what that token is within an MS build file, and that parameter there, sorry it's jumping around a bit, represents this item group, because that's the same name as that there. So what it's going to do is going to go and have a look at these assembly.cs files. So if I actually go into my solution and look inside properties, assembly.cs, we know that's there because that's where all the information for the builds are about, for the building the assembly is about. So what I'm actually going to do here is I'm going to edit this assembly info CS and put that placeholder in, so that when it does pull this down from the source control, the regex will actually catch it and inject this in So if I just put TFS build number, and what it will do is it will replace this token here with whatever it's going to inject in, which is actually the build number. Now the reason we do that is as follows. When I demonstrate this is when I check it in. So we're going to check that in now. So we're just going to say modify the assembly info. And while that's checking in, effectively this stuff here is downloaded from a Coplex website. So I'll add all the links to the show notes for this in terms of what you need to install on the TFS server for this to actually be able to be imported. So now that's done that, what we can do now is queue up another build. And while that's building, we should be able to see what's going on by double clicking in here. And you see it's still running now, so it's saying that the build steps aren't available, so my TFS server is definitely slowing down. It's more than likely because I'm recording this with Camtasia at the same time. So you can see there now it's grabbed the sources, and that will be down into the temp directory that we set in the build agent, and wallop, it's done it all. So now if I jump in and click in here, if I go into the releases folder now and right click, we should be able to see when we go into the details that we know exactly what build number this has come from. So it's number 2. So this now allows us, as developers, to not have to click and rack our brains to try and work out how we get that source for that exact DLL back again. Because we can just simply look for the build number, and then we can just come into our team project and we can just do a get latest against that change set, which would be 2. But that's where I'm at already because I'm checked in at that point. So hopefully that gives you a bit of an idea of the advantages of stamping those builds and being able to dig into the WSP file that we create to be able to see exactly that. And again, we could manipulate some of these things as well, so that before we run WSP Builder, we could, for instance, be looking at some of the solution info to add the build number into the WSP project as well. So the next thing, once we've got the build number stamped inside the assembly DLLs, is we really want to be able to do a quality check on the quality of the code that's being checked into source control. And we can leverage a tool called SPWebCast, which the Microsoft product team have released for us to run against our code to make sure that we're disposing of objects correctly. So what I'm going to demonstrate now is how we set that up. So effectively what we need to do is ensure that DisposeCheck is actually on the build server. So the first things we're going to do is ensure that by going and installing it. And what we can do is we can add that path to our TFS build file project, so that we can tell the build server this is where SPWebCast is installed on your machine. So the reason it's taking its time there is because it's having to check out the file first. So we actually give the exact location of where the SPWebCast is. Now the reason we have this DLL reference path is because with SPWebCast I've written a custom little widget which we need to add into our supporting files. So I'm just going to drag that in here. It's just called SPWebWiki Team Foundation. So now that's added, we can go back in here. So we need to reference that in a minute. And also we're going to have to give a location of where we want the SPWebCast log to be written to. And what we're actually going to do is we're going to copy that up to the solution root. And that's all we've added from that perspective. Now the next bit we just simply copy and paste. This is as easy as that. And there's nothing needs to be changed there. That's going to give us exactly what we want. Just to walk through it, effectively we're overriding or adding to the, before we do a drop build within the default team build tasks, we're going to call a target called SPDisposeCheck, which is actually part of this MS build file, which is called there. And what we're actually doing, which is really nice, is we're creating a build step within our build. And what I mean by build step is, if I go to completed build, I'm creating another one of these. We'll actually get a line entry in here for our SPDisposeCheck calls. And what we're going to do is we're going to actually execute the SPDisposeCheck tool, pass it the binaries route, which is the location where all the DLLs for this build are being put, and we'll output into that log location, and just setting the working directory of that binaries route as well. Then what we're actually going to do is we're going to run my custom task called SPDisposeCheck task, which I've written, and what that does is it'll actually, we'll need to add a reference to that. So I'm just going to grab that from another build file. So this custom task called SPDisposeCheck task is going to be part of, if I scroll across, the assembly file which we just put into our source control under supporting assemblies. And effectively all that does is it reads the log file and it looks to see whether any errors were reported by the dispose checker, and if they were, it adds it to the build file logs. So now if I save that like so, we should now be able to, if I check this in, sorry, wrong way, come on TFS. My VM's having a think. Okay, let's come back to life again. So I'm just going to say added SPDisposeCheck to build. We'll check that in. And what we should see now is if I go to Team Explorer and queue that one up, that's actually going to now, as part of this, once it's just before it's about to drop the builds into our build folder, it'll run this check over the assemblies that have been compiled. Now the interesting thing as well is what we can do is, rather than drop the log location into solution root, which is the temporary location that it pulls everything down in, effectively what we can do is we can pull that into the drop folder with the build number that we require, so it's actually in with everything else. So I'm just going to grab that from another piece of code that I've got here. And again, you don't have to include this SPDispose log in each drop, but sometimes it's easier than having to crawl through the overall build log to see what the error is. And the reason I will demonstrate this is because I actually want to show what this does when it does fail a build. So you'll see that that one passed, and you get a big tick on your SPDisposeCheck, which is nice. But what I want to demonstrate here is that we can actually prove that part of our build will highlight if we have poor quality in our code. So the way I'm going to do that is I'm going to edit our out-of-the-box web part that WSP Builder gives us, and I'm going to go and do something really naughty. And I'm going to get myself an SPWeb object as well. We're going to open that and have even more objects in memory. And then I'm actually going to grab my web. The reason is it's not doing that is because I haven't got my thing on there. And I'm going to get my title out. Oh, got a typo in there. So if I build that now, that's succeeded. So as a developer, that's cool. I've done that little task that's been asked of me, and I'm just going to check that in. So made change to web part to output title. Developer's happy. He can go away and have his cup of coffee. And that will get checked in, and he'll walk away, and that might get put into production next week, and 1,000 users will hit that web part 100 times a day, and you'll have a nice little memory leak on your server. So the build agent won't let the developer get away with that. Now again, it would be set up so that it would automatically queue a build, but I'm actually just going to queue one there manually for now. And hopefully what we'll see now, if my code's all correct, is if I double click on this build agent, is this is going to be spinning through, and it will report out once we get there that there was an error. And you'll see here that we've got a big cross by our SPWebCast. And if I went and had a look in the build log and I scrolled all the way down to the bottom, you'd actually see that the build failed. And if I looked up a bit further, you'd say that there was an error, that SPWebCast found errors, and it found 2. And surprisingly enough, it's reported that statement requires that it needs to be disposed, and so does my open web statement. Magic. So if you had up your build server and it had a big flashing light or a noise horn or something that fired every time a build failed, that developer will be ducking for the covers. So I'm just going to go and fix this now as a good citizen on this development project. And again, it's taking a while because it's, if you see down there, it's checking the item out from my development TFS server. And we're going to just put using statements around our objects so that once the object's been used, within that title block, they will get disposed of and the memory objects will be cleaned up. And therefore, if we get 1,000 users viewing that web part, we won't get the leak. So I'm just going to put fixed leak. And what we can do as well is that when that build fails, we can actually get it creating issues, the work items that then need to be associated. So we would be coming into our work items, picking the word icon for this project, and saying that we've now fixed that build error. So I check that in, and again, if we had that set up with automatic, it would automatically queue that build. I'm just going to kick that one off manually now. And hopefully we should find now that our SPWebCast is going to give us a big green light for that. And I hope that if, as you're watching this, you can really see the benefits already of what automated builds and continuous integration does for the development process from that perspective. Because we're catching these things before we even get into UAT or into our test environments where we were deploying these WSPs, because the administrators will be the ones having a look at this, and they will be the ones grabbing the latest release before they went into test, and they'll be able to see exactly which ones were failing. So now you'll see that's worked, and if we come in here and had a look at our releases, that would be the DLLs we would be using. So now that we've created that SPWebCast and we've stamped the DLLs, we want to get to the juicy stuff now, which is actually creating the WSP package so that we can just hand all this over to the administrators and they can deal with it right from here. So this one's actually quite straightforward. We want to do this after the SPWebCast because if that fails, we don't even be bothering to build a WSP because the quality is not good enough. So we're going to simply create a new target and call that there, which is WSP Builder, and I'm just going to grab this code. Now again, that's just straightforward standard code. Every project would have the same one, so you could just have a template for that. I found that my snippets have stopped working in Visual Studio, so I wasn't able to do that for this demonstration. And the only other variable we need up the top here now is where WSP Builder is installed. So I'm just going to add that into there. Now by default that's where it will get installed in most environments. So now that's done, what that's going to do for me now, if I just have a walk through this, is create me a brand new build step just purely to highlight that WSP builder is being run, and it's going to execute the WSP builder with various different things. It's going to be in release mode. It's going to create me the deployment files that I require to run this as STS-ADM, and just passing a few other different parameters, which you can look at in the source code later on. And we're going to just call that, we're going to then go through and grab the WSP file that's been generated from that execution and any relevant files that were created in the deploy folder. And you can see here this asterisk is like a wildcard for all files. And then we call a copy statement for all those files that were in that wildcard grouping, and we're going to drop those into the drop location there. So when I check that in now, what you will see TFS really doesn't like me unchecking those things, does it? What you will see, so if I'm just going to add WSB builder, build step, check that in, and I'm just going to queue up that build. Queue it up. Close that down. So if I double click in here, we should see that starting to run at the top. It's in progress. Now again, this is another reason why you really should be looking at a separate build server for your TFS, because if you've got a big team doing source control and you've got all this stuff going on as well, you are going to see some performance implications. So you can see there it's passed the SPWebCast check because we haven't changed anything in that code, and it's now going through the WSP builder step. So we're in the hands of the WSP builder cost and Koopman gods at the minute in terms of hopefully that working and creating a WSP file for us. And then what that will do is it'll go and copy that up into our release build. So that all succeeded. So if I click on that now, as if by magic, we have a WSP file created for us. We have our STSEM things which WSP builder built for us with exactly the correct things in here. And we have our build log with the whole history of exactly what happened to actually create that file. So I hope this really does show you the benefits of that in terms of how easily that is to build that, and for an administrator now to just come in here and hop and grab build number 6 of this web part and go and deploy that to test without having to get an email or a developer to dump something on a share somewhere for them to grab without all the source control. Because now we can actually, if we do get this WSP file and it's on a server somewhere, if I open this up as a cab file and we have a look, we copy that file out and we have a look in here, we go to the details, we're allowed to be able to see that that's the build number .6 that's been used. So it's really compelling from that perspective. I'm just going to delete those. So I hope that gives you a bit of an example. I will just demonstrate that if I do go in here, and if I do go back to my dodgy developer coding hat, and remove these checks, so the SPWebCast check will fail, that it will never actually get to the WSP builder step, so we won't get a WSP out, so we won't be building any code, we won't be building any packages that we shouldn't be releasing to any environment, regardless of whether it's a dev or an integration environment. So hopefully that will build. So we'll check that one in. Dodgy code checked in. And we'll queue up that. And we'll just going to double click in here and have a look at it as it's running. And hopefully what we should see here is that it fails on the SPDispose check. And as I say, you can see, oh, there you go. So it's failed on that SPDispose check, and you'll see that we don't get anything. But if we look in the build log and we search for the word failed, because these logs are huge, is it failed? And you can see here that that's the information when we get our logs, so we'll be able to see exactly what that is. So there you go. That's your quality introduced into your development lifecycle process. Okay, thanks very much for taking the time to view this webcast. Please bear in mind that you can subscribe to an iTunes or an RSS feed to be able to pick these things up more frequently. I encourage you to check back on the SharePoint Dev Wiki because I will be doing a lot more of these in the future.